So right now, today, like till day before yesterday, we got to know about how to write the time period. Okay, might not be. Now it is good. Okay, so till yesterday, we got to know what can be the velocity of ball when it rebounds and what is its time period after successive collisions and all, something like that. We found out, isn't it? The point was like we want to write. Let's suppose if I want to write how to write this time period equation and all those kind of things. So we'll move on to that. We'll still go on with the help of this, like the concept of successive bouncing of ball on ground. Okay. So we still will look forward to this case where we want to understand how the rebound occurs and what is the actual condition. Okay, so let us just once again bring those things. I have a, let's suppose, some kind of a ground. Okay, and on top of it, a ball is falling. Let's suppose I drop a ball. Okay, and this ball is falling on top of this ground. Are you able to get me or not? So I just released it. I just released it. The concept was this is height h. Okay. This is my ground, which I denote it as B. Okay. Its speed is always 0. How much is its speed? 0. So let's say this is ball A, which is once going down, then then once again what it will happen? It will come nearer to the ground, then it will bounce back over here or not. Yes. Then once again, it will go till some height. It will not rise up to that maximum height. It will go some height. Then once again, it will, yeah, it will go, yeah. So every time the height will go on decreasing and so on, isn't it? So you are going to see that this height has been decreased after the successive collision with respect to ground. Are you able to get me or not? Means these heights are going down and down and down. Similarly, the time period of traveling will also go down. Are you able to get me? And suddenly the ball will stop. So this is like this kind of motion. And it goes up. Okay. So it's doing something like that. Is that clear? Okay. So I have just represented like this way. Now the point arises that what is the total time period or something like that. Okay. What can be the total time period of this ball? If we have to find out what will be the total time equation. So we calculated that during the first time period, t dash means just after the first, yeah, if this is h and this was t, time of light to come down, then if this is height h dash, then h dash was exactly equal to e square h, isn't it? And the time to go over there is t dash was equal to e into time period. Are you able to get me or not? Is this clear? So let's suppose if there are n successive collision. Once again, if you put e square h, velocity and all those factors, once again you'll see that this h double dash, this is the second collision, isn't it? So this becomes for second collision, it will become e to the power of 4h. Are you able to get me or not? And so on. So basically, for every nth collision, the height reached is given as, जो height आता है that height is given as the height formula for every h nth. Okay, it is e to the power of twice nth into original height of the fall. Are you able to get me or not? Is that clear? Similarly, for every nth collision, the time period, the time of flight is given as not time of flight. Uh, you can say, should we write time of flight? Time of flight is twice of whatever we are getting. So, the time of flight, yeah, time of flight or time of fall is given by, I'm writing total time then, twice of e to the power of nth, t nth, it is into the initial time t. Are you able to get me or not? Is that clear? So therefore, let's suppose if I want to find the total time after which the ball stops or something like that. So total time t is given as what it will be. It will be first is t, second time it will be twice of t1, third time it will be twice of t2 and so on, isn't it? So that is why it is written as t. Twice of t1 means twice of et1, isn't it? Et1, sorry, et1 is et plus twice of this will become, this is second, so e square t. Are you able to get me or not? Third collision, e twice of e cube t. Are you able to get me or not? And so, is that clear? So therefore, t can be written as, if I take t plus here twice t common, it is e plus e square plus e cube plus and so on. So this is particularly given as, it is like e plus e square. So it is given as t common. I'll just write, or let us write t plus twice t. It is written as e by 1 minus e. That's the formula of 1 plus 1 square plus 1 cube plus 1 and something like that. Are you able to get me or not? Yeah. So if you just replace it, what you are going to get is, it is this will be t is equal to twice t. It will be t minus of t, and that is twice t. So it is, you will get something like t plus, sorry, te, isn't it? Divided by 1 minus e. Is that clear? So therefore, that is why total time of flight was given as, t was given as t common 1 plus e divided by 1 minus e. That's my total. I have directly solved that. Check that. I have directly solved that. We'll get the same thing. Okay. Now you know that a small t was given as root 2h by g because only height was mentioned, isn't it? So therefore, time of flight is given as, t is given as root 2h by g 1 plus e by 1 minus. Are you able to get me or not? Similarly, there can be total displacement after which the ball will stop, isn't it? So it is given as h is equal to h. I have written h over here. Okay. So h total. One minute, let me write. H total is given as h plus twice of h1 plus twice of h2 and so on, isn't it? H plus twice of h1 is twice e square h capital H plus e to the power of twice e to the power of 4 into capital H and so on, isn't it? This will be my equation. Okay, so once again, take the common h plus twice h common e square plus e to the power of 4 plus and so on. Is that clear? Now, 1 minute. Let me 1 minute. I think I will not get it in easy way. Let me take another thing common. Mhm. H plus. Let me take twice because without adding one we will not get anything. So twice e square h common. So it will be 1 plus e square e to the power of 4 and so on. Are you able to get me or not? Now once again this is same. This is 1 plus something. So it is written as h total is equal to it is given as h plus this will be twice e square h and bracket 1. No, it will be just 1 by 1 minus e square because it is x square form. Are you able to get me? Is that clear? So if I take h common, so h total is given as, let's suppose if I take h common, so it will be 1 minus e square plus twice e square divided by 1 minus e square. Got it or not? So what you got as, once again you got the h total relation. So the total height after which the ball stops is h 1 minus a square by 1 plus a square. That's your relation. Sorry, 1 plus e s. 1 minute, 1 minute. That is 1 plus e square by 1 minus a square. That is your total height. Are you able to get me? Uh-huh. So next thing is you can find the average velocity also. So average velocity is total distance traveled divided by total time, isn't it? So what's my total distance traveled? If you see that total distance traveled is it is h total. 1 minute, I forgot to mention here. H will be also present. H 1 plus e square by 1 minus e square divided by total time. So I'll directly write the reverse form. Okay. So total time is root under twice h by g 1 plus e by 1 minus e. So it will just interchange, isn't it? So it will be root under g by twice h 1 minus e divided by 1 plus e. Are you able to get me or not? Here, one. So what it will be left with? It is left with h 1 plus e square divided by this is same. This is twice h is same. So 1 plus e square 1 minus e 1 plus e bracket close root under g by twice h 1 minus e by 1 plus e. Again, so this and this got cancelled and I am going to get root under average velocity is root under gh by 2. I think I should switch off that background. It's getting problem. Yeah, not root under gh by 2. 1 plus e square by 1 plus e whole square. That's my average velocity lesson. Are you able to get me or not? Okay. Similarly, you can find average velocity. Oh, sorry. I for this is average speed. Average speed is total distance by total time, no? So average velocity is displacement by total time. Now look over here. If the ball rebounds so many times, so look over here. For this rebound, yeah. So for these successive rebounds, the displacement is zero or not. But one displacement is left over here, which is top h, isn't it? So that is why the net is uh, and total time is h 1 plus e by 1 minus e. यही था ना? t was, sorry, root under twice h by c. Root under twice h by g, 1 plus e, 1 minus e. Yeah. So this will become, I'll just write root under gh by 2, 1 minus e divided by 1 plus e. This is my average velocity. Okay. Done. So we did this, all of these case. Now, what we have to actually look is something typical. Right? So that typical will do right now. Hey, I'm recording the session now. Yeah, I'm recording it. I thought I am not recording it. Okay. So what I'm going to do, I'm going to give you some exceptions now, and that will provide us the relation for two body collision or something like that, correct or not. So let us work. Now we got through many different kinds of collision and all, but there are, see, if we look into the consideration, we have total collision in terms of five bases, isn't it? But actually there are two bases. Out of that, there are, I'll show you how to understand this. Okay, so let us see. Basically, if we look into the types of collision, okay, so this collision is divided actually. Our collision is dependent upon two things. One is basis of energy, okay, and one is basis of line of impact. Are you here? So there are two kinds of collision. Okay, first one is on the basis of energy. We divide into three parts. One we call it as elastic, which we have already know, where E value is how much? Perfectly elastic. Let us write perfectly elastic. So E is exactly equal to 1, isn't it? That means a reformation, impulse of reformation is equal to impulse of deformation. Then there was perfectly inelastic, where the body used to stick together. That means E was equal to 0. And then there was inelastic collision, where E used to lie between 0 and 1. But basis on line of impact, we have two more collisions, head-on collision, and there is oblique collision. So we will look into the case of head-on collision with these three different types. Like head-on can be perfectly elastic, perfectly inelastic also, or inelastic. Inelastic is normal. You'll have to use the convention. But perfectly elastic and perfectly inelastic has some exceptions over there. Are you able to get me or not? So let us go through that. The first one, which we call it as head-on collision. Are you able to get me? Is this clear? So let us give the first case, head-on elastic collision. See, basically you have to remember one thing that in perfectly elastic collision, kinetic energy is conserved, isn't it? And that makes us to have, see, in all of these, one thing is common that they follow initial momentum is equal to final momentum. Yeah, but one thing is there present in perfectly elastic collision, which is kinetic energy conserved. So this makes the elastic to have two equations, one of momentum, one of kinetic energy, and which makes us trivial to relate some velocity factor out of that. Are you able to get me or not? That means E is exactly equal to 1 for these kind of collisions. Are you able to get me? So let us see that. Let's suppose if there is mass m1, okay, moving with some velocity v1, and then there is mass m2 moving with some velocity v2. Right or not? They got collided. So what will happen? Uh, some part of mass m1 and m2 will be deformed. So this is m1, this is m2. At that time, they're moving with common velocity. Are you able to get me or not? Then once again they get separated. M1 that moves with I do not know which velocity, and M2 that moves with which velocity we have to check. Are you able to get me or not? Sorry, let us just use our convention. Let us just call it U1 and U2. This is V1, and then they move with V2. Are you able to get me or not? So first, we know that F external is 0. So initial momentum is equal to final. This implies initial momentum of the system you have to write always. Remember that this is F external of the system. Are you able to get me or not? So this is why M1 U1 is my initial momentum plus M2 U2 is my initial momentum, that is equal to M1 V1 plus M2 V2. Are you able to get me? Next thing, as E is exactly equal to 1, so you have it is equal to velocity of separation, that is V2 minus V1 divided by U1 minus U2. So V2 minus V1 is equal to V1 minus U2. That is one of your another relations. Got it or not? So basically, I can directly write our V2 value. So let's suppose if I just put V2 is equal to U1 minus U2 plus V1. Got it? In this first equation, okay, if I just replace it, what I'm going to get? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 U1 minus M2 U2 plus M1 V1. Are you able to get me or not? Is that clear? So this means we got the relation for V1 actually. If we are aware of V1 and U2, then V1 is known to us. I can directly write V1 as 1 minute. Look over there. If I just write, I can write V1 in terms of now. So it is M1 minus M2 into U1, ठीक है, प्लस इधर इसको इधर लेकर जाओगे तो ट्वाइस M2 into U2 divided by that is M1 plus M1 plus M2. I think there should be, yeah, sorry, here it should be M2. Okay, M1 plus M2. Are you able to get me or not? That is your relation. So V1 is twice of M2 U2 plus M1 minus M2 into U1 divided by M1 plus M2. For V2, you can just replace this and interchange. Okay, I'll write I need to change it. I'll just write it. So V2 is given as, just replace it. We can interchange this. One thing is common. See, learn the trick how to write it. M1 plus M2 is common. Okay. this will be twice of m1 into u1 now, got it or not, plus it will be m2 minus m1 into u2 right now. Are you able to get me? So this is your particular v1 and v2 cases over there. Is that clear? Now, for these elastic collision, there are many cases to understand. See, पहली case है, let's suppose there are two balls which are going to collide, which are traveling on this smooth surface, okay, and this is m1, this is m2. The speeds are different, v1, and this speed is v2. Okay, but one thing is very common in them, that first case of that head-on collision, head-on elastic collision, that m1 is exactly equal to m2. They are following which collision? Head-on elastic collision. सोचो जरा, अगर मान लो कोई तुमसे पीछे से धक्का मार रहा है और इलास्टिक कोलिजन है और तुम्हारी मासेस सेम है, तो क्या होगा? क्या ये दोनों वैल्यूज, मतलब सोचो जरा, ये v1 और v2 में ये m2 और m1 दोनों बराबर है, तो ये कैंसिल हो जाएंगे ना? हाँ, मतलब सॉरी, 1 मिनट, एक काम करो, इसको u1 u2 लिखो, तो u1 u2, तो ध्यान से देखो, ये वाला टर्म जीरो हो जाएगा, ये क्या हो जाएगा, ट्वाइस ऑफ एम कैंसिल हो जाएगा, तो बचेगा क्या, u1 बचेगा ना सिर्फ। तो दिस इम्प्लाइज क्या हो जाएगा यहाँ पे, v2 will be equal to, the first conclusion we draw, that v2 will be exactly equal to u1 and v1 will be exactly equal to u2. That means velocity gets interchanged after collision. अगर मासेस सेम है और हेड ऑन इलास्टिक कोलिजन हो रहा, तो वेलोसिटी आफ्टर द कोलिजन क्या हो जाता है, इंटरचेंज। क्या हो जाता है वेलोसिटी आफ्टर द कोलिजन? हेलो, कैन यू हियर मी? हेलो सृष्टि, कैन यू हियर मी? तो ये वेलोसिटी क्या कर जाती है, इंटरचेंज।